Hey everyone, welcome back to Root Code. Today let's solve a problem to search an element in the given array using the binary search algorithm. This will be the iterative method. Okay, let's get into the program. Hash include stdio.h. Now first I'll write the search function. So int search, and the parameters will be an array of type int left, int right, and int key. So I'll run a while loop while left is greater than or equal to, sorry, lesser than or equal to right. Now I will create a new variable called int mid that will be equal to left plus right by 2. Okay, now if array of mid is greater than the key that we're looking for, then we have to move the right element, or we have to update the right value to mid minus 1. Right is equal to mid minus 1, else else left is equal to mid plus 1. If left is not greater than, if left is not lesser than or equal to right, we will have to return minus 1. I think we missed one condition, which is if array of mid, this is the most important condition, if array of mid is equal to the key, then we will return mid. And let's make this else if. Alright, now let's get into the main function. Int main. First I'll declare a variable int key and then prompt the user to enter the element to be searched. Scanf %d ampersand key. Next we'll initialize the array. So this is the array 0 1 2 3 4 5 6 7 8 9. Let me copy and paste that here. To find the size of the array, int n is equal to size of ARR divided by the size of one of the elements, size of ARR 0. If we simply do size of array, it will return the bytes, like the number of bytes the array is taking. So we have to divide that by one of the elements to get the size of the array in terms of how we're going to count it, like 0 1 2 3 4 5 6 7 8 9 10. So there are 10 elements, right? Now I will create a variable called result is equal to here I will be calling the function search. I will pass the array, left will be 0, right will be n minus 1, and key will be key itself, because even in the main function we have declared it as key. If result is equal to -1, printf element not found in the array. Else printf element found at a of %d result, and then return 0. So this should do it. Let me save and run the code. Alright, The array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Enter the element to be searched. I will enter 8. An element is found at a of 8, which is right. Let me run it again. Let's look for an element on the left side of the array, maybe 3. Element found at a of 3, which is right again. Let's now try something that's not in the array, say 10. Element not found in the array. So this works. Now, if we want to solve this same problem with the same algorithm but using recursion, we will have to make a few tweaks in the function. Let the parameters remain same. I will first write the base condition, which is if right is greater than or equal to left, int mid is equal to left plus right by 2. If ARR of mid is equal to key, then return mid. Else, if ARR of mid is greater than the key, then return the function search. I'll pass the array. We will have to update the right if the middle value is greater. Yeah, we'll have to update the right variable. So left will remain as it is, and right will be mid minus 1, and key will remain as it is. Else, return the function ARR. Now the left should get updated, mid plus 1. The right will remain as it is, right and key. Yes. Now outside the if statement, this is the condition where right is greater than left. We will simply return minus 1. So let me save. I think that's it. Even while passing the parameters, this is all we'll have to do. Now let me save and run the code. Alright. So the array remains the same, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll first look for 8. Element found at a of 8. Let me run it again. Now let me look for 3. Element found at a of 3. Let's look for 2 maybe. Element is found at a of 2. Now let's look for something that's not in the array, say 33. Element not found in the array. So we have successfully solved this problem by using both the recursive and the iterative method using the binary search algorithm.